Hey guys, welcome back to the 2015 Level 2 Physics Mechanics exam. Alright, so let's just move on to question 4. Circular motion and torques. Janet swings a ball tied on a string in a horizontal circle above her head. Explain why the ball is accelerating, even though it's swinging at a constant speed. So basically, the ball is still accelerating because there is unbalanced force from the centripetal force acting on the object. And because F equals ma, and because there's an unbalanced force and there's a mass of the ball, therefore there has to be an acceleration, okay? So basically, like, the velocity is constantly changing because even though the speed is the same, the direction of the velocity is constantly changing, and therefore the ball is accelerating, okay? So we're gonna say the ball's traveling at a constant speed, but it's constantly changing direction, okay? Because acceleration is defined as the rate of change of velocity therefore there is an acceleration. Alright, so basically so the ball in circular motion is accelerating, and basically getting up to here is getting you an achieved grade, okay? So you have to say that the ball is traveling at a constant speed, is changing direction, and therefore there's a change in velocity, and because there's a change in velocity, and therefore there's an acceleration, okay? That'll get you an achieved grade. The length of the string is 0.75 meters. It takes 0.84 seconds for the ball to go around her head once. Calculate the acceleration of the ball. Okay, so basically we know that acceleration equals to v squared divided by radius, okay? So right now we don't know the velocity, okay? So the length of the string is 0.75 meters, okay? And it takes 0.84 seconds for the ball to go around her head once, okay? Okay, so we know that v equals to 2 pi r divided by t. Okay, so we have so 2 pi r to find the circumference, and then t as in the period. So how long it takes for it to go around once, okay? So basically v equals to 2 pi multiplied by 0.75, and we're going to divide that by 0.84. Okay, so therefore if you plug this into a calculator, you should get that v equals to 5.61 meters per second, okay? So now we can plug in v equals to 5.61 meters per second into a equals to v squared divided by r. We'll substitute v equals to 5.61 meters per second. So we're going to say radius equals to 0.75 meters, okay? So we're going to say a equals to 5.61 squared divided by 0.75. And the acceleration should come up to a equals to 42 meters per second. Alright, so that should be your final answer. And getting up to here will get you a merit grade. To find the acceleration, get you a merit grade. And to get an achieved grade, you're looking at correct answer for velocity. So velocity equals to 5.61 meters per second, or you have or a minor mistake, okay? So basically getting up to v equals to 5.61 meters per second, you'll get an achieved. Alright, moving on. Name the force that causes the ball to accelerate as it goes in a circle. Explain why the force causes the ball to accelerate. Okay, so the force that causes the ball to accelerate is called centripetal force, okay? And the ball, because the centripetal force provides an unbalanced force, and because of the unbalanced force, and F equals to ma, therefore there's an acceleration, okay? So we're going to say the force acting on the ball is called centripetal force because there is an unbalanced force acting on the ball, and F equals to ma, therefore there is an acceleration. Therefore there is an acceleration on the ball. Okay, so basically you're going to say that there's a force acting on the ball and it's called centripetal force, okay? And because there's an unbalanced force on the ball and F equals to ma, therefore there is an acceleration of the ball because F equals to ma, and there's a mass on the ball, and there's an unbalanced force, so therefore there has to be an acceleration, okay? To get a merit grade, you have to say that okay, so you have to say what provides it. Sorry about that. So you also have to say sorry about this. I actually forgot. You have to say the tension force. The tension force is the centripetal force. Okay, so by saying that the tension force is unbalanced force, and because the unbalanced force and F equals to ma, therefore there's an acceleration, okay? You'll get a merit grade. To get an achieved grade, you're looking at the force is called centripetal force, okay? So basically, just this first line here will get you an achieved grade. But for merit, you have to say that there's a unbalanced centripetal force acting on the ball, and because F equals ma, therefore there's an acceleration. So you have to link it back to get a merit. Janet's study table has 2 panels, one at each end. Janet has a pile of books on her table. Use the details given below to calculate the support force provided by panel A of the studies table. Mass of the table is 37 kilograms, length of the table is 1.5 meters, mass of the book is 7.4 kilograms, and the weight of the books are at a distance of 0.45 meters from the end B of the table. Assume Janet's study table is uniform. So we're trying to calculate the support force provided by panel A. So we're going to find over torque around the opposite point, okay? So opposite support force. So we're going to find over torque around B, okay? So we're going to say B is the pivot, okay? So you know that there's a weight force acting by the table downwards, okay? And that's from the center of the table because Janet's study table is uniform, and because it's uniform, the center of mass is at the middle of the table, okay? So this to here, it's 0.75 meters, and from here to here, it's also 0.75 meters, okay? Okay, so we know that torque equals to FD, right? So mass of the table is 37 kilograms, but we have to convert that to force, okay? So F equals mg, so therefore 37 times 9.8, 37 times 9.8, what does that give you? 37 times 9.8 gives us 362.6 newtons, 362.6 newtons, okay? And that is 0.75 meters away from the pivot. That's 0.75 meters away from the pivot. So torque equals FD, so 362.6 times 0.75 equals 2. So let's say times 0.75 equals 2. 271.95 Newton meters, okay? So that's the torque of the table, okay? But we still need to find the torque of the books, okay? So the mass of the books is 7.4 kilograms. So we're going to say 7.4 times 9.8 equals to the force. So we're going to say 7.4 times 9.8. That should give us 72.52 newtons, okay? And you see that the distance from support B is 0.45 meters, okay? So I'm going to say 72.52 times 0.45. That equals to 32.63 Newton meters, okay? So the total torque, okay? So total torque around B. So total torque around B is the torque of the books plus the torque of the table, okay? So that equals to 32.63 plus 271.95. Plus, you add them together with your calculator, and that should give you 304.58 Newton meters, okay? Right, so now we're going to say, okay? So now we're going to say that torque equals FD. So torque equals FD, and because A is 1.5 meters away from B, right? So the distance is distance from the two supports is 1.5 meters, and the torque around pivot point B equals to 304.58 Newton meters. So torque equals to 304.58 Newton meters, okay? So now we're trying to find the force exerted by end A, okay? So now we're going to substitute torque equals to 304.58 Newton meters, and distance between the two support forces is 1.5 meters, okay? Because torque clockwise equals to torque anti-clockwise, okay? So torque clockwise equals torque anti-clockwise. I'm going to say 304.58 is equal to 1.5 F, okay? So if we divide 304.58 by 1.5, you should get F, and that should give you F equal to 203.06 newtons. So that should be your final answer, is 203.06 newtons. Getting all the way up to 203.06 newtons will get you an excellence grade. To get a merit grade, okay, you're making one minor mistake, okay? So for example, you found the support force of B instead of A, you'll get a merit grade, okay? So merit, and again achieved, you're looking at the total amount of torque calculated correctly. So you're finding the 304.58 Newton meters, that'll get you an achieved. Alright, thank you for watching this video on the 2015 Level 2 Physics exam walkthrough. If there's anything you're still confused about, please leave it in the comments below. I'll answer your comments, okay? Until then, I'll see you in the next video. Thank you. Bye.